Login accepted.
Okay, good morning. First of all, I would like to thank you all for coming to the lecture. Today we'll be discussing the place of GraalVM in the cloud solutions world. And to be a little bit more specific, in the serverless solutions world, just like the title suggests. A few words about myself. My name is Maciej Kołodziejczak. I'm a senior technical lead for a company called Datev. I am a Google Cloud engineer. I've been part of AWS Builders community for quite some time, and in general, I've been building cloud-based applications for a while now. But all of those certificates, positions, and titles aside, in my heart of hearts, I consider myself a Java developer. And that's because it's the technology with which I worked most of my career. It's the technology with help of which I like to build my applications. Now, Java in cloud solutions world takes a rather peculiar place, as in it's great in some setups, like scalable container applications. I mean, we've been using containers to build our applications for many, many years now. If you combine it with clouds, it works great. However, it can completely suck in some other setups. For instance, serverless applications. I assume most of you are familiar with serverless applications. To a few of you who might not be familiar, I'll do a quick introduction. And an analogy I like to borrow from Jeff Delaney to explain that best is to imagine that we've just built a house. And in that house, of course, we're going to need water. Now, we can spend a lot of time and money digging a well. Then, of course, we'd have to test the quality of the water. After that, we'd have to cover all of the plumbing work. Or we could just simply tap into the city water supply and pay a monthly fee based on our usage. And that's what a serverless application is exactly like. It's basically a piece of business logic that's being triggered immediately and on demand, but without the necessity of configuration of server and maintenance of the server. Languages like Go or Node.js are great for writing code, perfect for that. Java, however, in and of itself, unfortunately, is not. And why is that, you might wonder? One reason we can state here is, well, because of its high memory consumption, at least higher in comparison to like Go applications or Python applications. But the biggest reason is probably the most obvious one, and it's probably the one that you've already heard of, and it's Java application startup time. Now, when we're triggering our serverless applications, we want the response to be returned immediately. While with Java, we have to wait for JVM to do its work. We have to wait for if we're using a framework, we have to wait for all of its components to load. And only then we can begin processing the request itself. Right, but the gist is the serverless applications are supposed to be stateless. It's not supposed to maintain any data. It's also supposed to be ephemeral. It's being used and discarded while the function has done its work. And all of that allows for a fairly nuanced billing system where we're only being charged for the resources that we used to run our code. Yeah, and the problem with Java here that we have here is that all of it takes a lot of time. And we can't really make users wait that long for the response. Because in today's world, they're just not used to waiting, and they might just leave. And what if we have like a process spanning over multiple services? All those wait times will keep on adding up, leading to a significant delay. But let's maybe have a show of hands. Let's maybe see if I'm wrong here. Let's see how many of you have ever created even like a basic REST API. And not just yet, not just finished. Like a basic REST API with startup time and processing time combined lower than 300 milliseconds. No one? Okay, so let's be generous, 500 milliseconds. Yeah, there are a few people, great. And of course, that's great, that's very impressive and all, but that's just a handful of people. And there are actually great reasons for it. One of the reasons, of course, is maybe that you've used frameworks to build your APIs, which of course make things significantly easier, but they do add additional overhead to startup time. The other reason is simply that in Java, getting down, even without the frameworks, even without the whole baggage of the frameworks, getting down to the level of like 300, 500 milliseconds, it's not an easy thing to do. And in some cases, it might be just simply impossible. Now, I'm inclined to tell you that the cloud service providers are very much aware of this issue. And they've prepared some solutions to maybe mitigate the so-called cold start problem. Right, that's the comparison of the languages. Right, and Microsoft Azure Functions prepared service called always on. It's called always on. And you might be getting a little bit suspicious after only hearing the name of it, always on. Like, how is it different than just keeping a running container? Well, in its principle, it's actually not that different, and it's only available in the highest price plan. In AWS, we have, of course, snapstarts, which are supposed to keep a preloaded context for a extended period of time after the first request. But it's not really stated for how long. And it's been observed that it's around 5 to 10 minutes, up to 15 minutes. Other than that, we can only rely on AWS provision concurrency, which is supposed to keep the preloaded execution context for well, basically indefinitely. And yeah, it's very similar to Azure Always On, and yes, it is very expensive. If we were to use Google Cloud Run, there's actually no built-in feature like that. The only thing we can do is to basically set up a minimal number of continuously running instances, which in my opinion sort of defeats the purpose of serverless, at least in the cases where we don't need a container running at all times. Just let's hold on for a second. And I don't know about you, but I'm not happy with any of those solutions. Because even if they do help with the cold start issue, none of them make Java an equally valid candidate for a serverless function. And that's because it's simply more expensive to run. And that brings us to the main subject of this lecture, which is GraalVM. So what is GraalVM? The main feature of GraalVM project is the novelty Graal compiler that can work both as a just-in-time compiler or with its native image feature, which is supposed to build application into the native machine codes ahead of time. There's also something called Truffle language framework, which is supposed to work with Graal compiler to run JavaScript, Node, Python, Ruby, and all of those languages on JVM. That's just some quick information for anyone who might be interested in that. It won't be the focus of today's lecture. The focus of today's lecture will be on those two. Right, so I know that the level of experience of Devoxx attendees may vary, so let's stop here for a second and let's get down to the basics. What is this whole just-in-time compilation? What is this whole Ahead of time compilation. Well, just-in-time compilation is basically compiling a JVM bytecode into native machine code at runtime. It's what we've known for decades. It's the default compilation mode of JVM. Because when we're compiling our Java program, of course, at first it's being compiled into the JVM bytecode, which is easier for JVM to interpret. After which it's being compiled to a platform-dependent machine code. And in the just-in-time compilation, that last part happens at runtime. As a matter of fact, in GraalVM, just-in-time compilation is possible as well. Furthermore, due to all of the aggressive optimization, the aggressive inlining, and partial escape analysis, it's been shown that actually using GraalVM just-in-time compilation can improve peak performance of long-running applications in comparison to traditional JVM. But besides just-in-time compilation, compiled, but besides application compiled with GraalVM with just-in-time compilation, running quicker than in JVM, there's also something called ahead-of-time compilation. And actually, the very idea of ahead-of-time compilation is nothing new. It's actually considered the old-fashioned way in which code in programming languages like C is statically linked and compiled into the hardware-specific machine code. And now, with GraalVM, we have that in Java as well. Right. So what GraalVM does in ahead-of-time compilation is that it compiles our Java application into this self-contained native executable that contains all of our application classes, that contains the classes from our dependencies, that contains runtime libraries, and also some statically linked code from JDK. All of the aggressive optimizations make sure that only the code that's actually going to be needed for the application at runtime gets added into the native executable. Yeah, there are also many techniques like code elimination, heap snapshotting, static code initialization that are intended to produce native executable that will deliver peak performance immediately without any warm-up that will start in milliseconds, and while we also using fraction of the resources that JVM does. And so it happens that it's actually something that makes it a perfect candidate for solution of our Java serverless application problems. So enough with the GraalVM intro. If you'd like to hear more, or maybe see like a broader picture of the whole GraalVM project, a bit later today there'll be a great lecture by Alia Yurienko about GraalVM. So if you're interested in the project, I highly recommend you see it. And right, so having the introduction out of the way, let's get into something I'm sure many of you were waiting for, and that is code. Right, so in a moment, we'll try to solve some issues where GraalVM could actually be of help to us. But just a quick disclaimer to any beginners or junior developers in the room that those examples may not be that beginner friendly, because I'll try to prepare some examples that'll be as close to real life problems as I possibly could, and unfortunately those problems are not that beginner friendly either. Right. So maybe let's set the stage. Let's imagine that we've all been hired by this renowned fintech company. It's a completely new environment. It's a completely new team, completely new setup. And in this company, the business requirements engineers decided to build a stock and market analysis system. The whole system is supposed to continuously ingest large amounts of data. It's supposed to process them. It's supposed to use this complex algorithm to analyze this data. And of course, the system is built in microservice architecture. Let me give you a look into it. Right, so it looks more or less like that. There's, of course, just a more architecture. But in the system, of course, there are multiple services. Some of them are responsible for ingesting the data. Some of them are responsible for actually processing the data. And the system will be responsible for, the service that we will be responsible for is the trade signal service, which is supposed to generate trading signals based on some regularities that were discovered in the stock market data. Right, so let's see the code. Okay, and what we have here is basically your standard Spring Boot application. Yeah, there are some controllers, there are some domain objects, there's a repository to read and write data, and there's a business logic in form of a service that's supposed to analyze the data, and based on this analysis, it's supposed to decide whether to send those trading signals or not. There are basically two use cases. One of these cases being we are accepting the data that the irregularities detector sent to us. We're analyzing it. We're deciding whether or not to send a trading signal. After everything is done, we of course saving the data into our database. Obviously, we want the whole process to be as quick as possible. Of course, we're discussing making decision that will result in buying or not buying some stocks. So we have no time to spare. It's an important decision to make. The other use case is just a recommendation that is supposed to be issued based on request. It's supposed to analyze the data we have so far, and it's supposed to issue a recommendation with some degree of confidence stated with which the recommendation was made. Okay, so let's maybe see how it works in practice. Here we have a table opened. I have some. Basically, the deployment process takes a moment, so I already did that beforehand, just to make sure that the service will have enough time to cool down, to make sure that the whole test will be as close to a real-life scenario as possible. So I also have some requests prepared with some quotations data. So let's pretend one of the other services actually detected some irregularities, and it's sending the data informing us about those regularities, and we're supposed to make a decision. Let's see if. Okay, here we can see that our service is actually up and running. So we might want to send that request. Okay. Obviously, we need to copy the right URL. Let's paste it. It's a bit too much. Okay, so now let's send the request. And okay, it went through. We can verify that in our database, that everything went as expected. Yeah, the Wi-Fi, the Devoxx Wi-Fi is not that great, to be honest, so it might take a moment. Right. Derecates were added, so yeah, it's cool and all, but the application we've built took around 10 seconds to complete the whole process, which I think we can objectively say that it's not that impressive. Right, and in this particular case, it can be a significant issue, because during this whole cold start periods, of course, our service cannot process any data, and that can lead to actual missed trading opportunities. So obviously, we cannot deliver a service like that. We have to do something about it. So what can we do about it? It also happens that a person in our team visited a conference lately, where people discussed this new popular technology called GraalVM. That's actually supposed to help with the startup time. So let's try it, right? Let's close this one. And open the other project. So this looks virtually the same as the other project we've previously done. We are using basically in our project a Spring Boot 3, so we can let Spring Boot 3 do all of its heavy lifting. It will basically prepare all the configuration files. It will analyze how the program will run at runtime, and it will prepare all of the reflection data, the reachability metadata that's going to be needed in ahead of time compilation. Of course, Spring Boot will not do it by itself. It will use its built-in feature for building native images. If we weren't to use a framework like Spring, we'd have to do it by ourselves, which honestly is not a fun thing to do. So using frameworks do help significantly, especially since in Spring 6 and in Spring Boot 3, the support for native image compilation is built in. In Spring Boot 2, I guess we could also make it work, but would probably have to prepare all the configuration ourselves. In Spring Boot 2, there's a separate Maven plugin, separate Gradle plugin, and unfortunately, the support for the integrated libraries is not that great either. But we are using Spring 3, so it's not something we should worry about. The support is built in, life is good. So basically, most of the work that we should do, that we have to do, is to add a new profile. And the profile question looks like that. Yeah, here we're stating we'll be using the native Maven plugin. This is also the place where you might want to explicitly state what resource files should be included in the native image. To maybe help Spring out a bit, because sometimes, unfortunately, it still needs some help. But in our case, this profile should suffice. So basically, to run it, all we have to do is to run a command maven clean package with our profile native. Excuse me. Or in our case, if you want to deploy this application to cloud, we'll just be using a maven command with Spring Boot goal called build image. Of course, I will not be do it right now, because unfortunately it takes a long time. It'd probably take like a third of this entire lecture. So just like previously, I've built it beforehand. I've deployed it already. And yeah, we can verify that it's still up and running. And it is. So let's see how well we did. Let's paste the new URL. And send the request. Okay, we can verify if everything went through correctly. Let's see our table. Of course, let's give it a moment. Okay, I guess the new record with ID 34 was added. So I think we can assume it went through correctly, and not only it went through correctly, it went through correctly much quicker. So I guess we can call it a spectacular success. And yeah, great work, good work, guys. But of course, this spectacular success does not mean we get to celebrate and pat each other's backs. It just means we are getting another project to work on. And this time, our next project will be a tax calculation service. Of course, our service will be called once a year. Let me give you a brief outlook on how it might look. Right. It looks more or less like that. It's less of an architectural design, it's more of a graphic presentation of what it might take to build a service like that. Of course, since it's a tax calculation service, it will be called once a year with a bunch of bank statements in a single batch. And let's maybe see what we have in our projects. Let's close this one and open this one up. So again, we'll be using a typical Spring Boot application. And what we have here is a single controller for accepting requests. We'll be using for some mailing service in case there is some formal request to share data needed. We have some domain objects, as always. We have some queue to maybe publish data into the Credit Information Bureau or something like that. We have some repository to read and write data. And we have a business logic in form of credit score calculator. Now, in this case, to make sure that our application will run correctly, we also have to integrate with a bunch of external services. And yeah, that can take a bit of memory. So let's see what's the performance like. As before, I took the liberty to this time not deploy the service itself, but to build the application and upload it into our Artifactory so we can create the service right now. Of course, we have to select the image from Artifactory. Okay, let's select the region. Of course, we want it to be Warsaw. Over here, at the moment, we'll accept all of the invocations. And we might want to also connect it into the database. So let's create it. Okay, and we have a failure. So let's get into the logs, see what's the matter. And the matter is that right, the error is that we run out of memory. We needed 637 megabytes. By default, it's only stated to be 512. So, yeah, out of memory error. Who would have thought? So let's redeploy it just to make sure that there's just nothing wrong with the application itself. Just let's add a bit more memory this time. Let's select 1 gigabyte. That should be enough. Okay, it looks like it's a success now, which means that our application works properly. But of course, more memory directly translates to higher costs. So of course, our management may not be happy with how pricey our solution is. So let's just say that during one of the meetings, one of you guys mentioned that, hey, how about we try this GraalVM thing again? Like, it worked the last time, and it's supposed to decrease the memory footprint as well. So how about we try it? When it comes to the code, it looks basically the same as in the previous projects. The only thing we did, it was added this new profile to make sure that Spring will build a native image. But let's deploy that image and see how it behaves. Let's go into our Artifactory, select the image. Right. Of course, again, we want the region to be Warsaw to make sure it be as quick as possible, and allow for all unauthenticated invocations. Let's get into the details, the configuration details. Scroll down a bit. Should we increase the memory? I'm feeling lucky, so I'm saying no. Let's scroll down a bit again. We need to connect it to our database. And create our service. Okay, and this time everything seemed to went well. And so why is that? Well, basically it's because the reason we've already discussed today is because when compiling into a native image, into this native executable, we're only using the classes that are actually going to be needed during the runtime. While in traditional Java, we have to load all of the dependencies, or the classes of the entire dependencies. And of course, after we did that, at startup, we need to load those dependencies into our memory. So basically, that's the reason why using GraalVM can reduce your memory consumption. And if you're using cloud services, that will directly translate to lower costs. Okay, again, well done, guys. You did awesome. Since we went, everything went so good so far, there's no point in stopping now. So let's imagine that this time, give me a moment. Okay, so let's imagine that this time, what we need to do is to create a credit score calculator. Of course, we want the calculation to be real time, and the application itself is going to process this vast amounts of data. It will use this complex algorithm to assess this data. But yeah, let's see that firsthand. Again, let's close this project. And open this one. Again, we just have a simple controller to accept the requests. We have some domain objects, we have repository for reading and writing, and we have our service. No, that's not the one. That's not the project I wanted. This one's the project I wanted. Right. So again, we'll be using like a bunch of libraries and a bunch of dependencies to connect to the external data, which can again influence our container size. And but yeah, let's this time we don't really need to actually deploy anything. We can just see it in our Artifactory. So let's get into our Artifactory. This is the container built with built with traditional JVM. It's about 160 megabytes. Now let's compare it to a container that was built with GraalVM. Right, and in this case, it's just 67 megabytes. And we can clearly see it's almost 60% smaller. And again, that is because it only contains the minimal classes that are going to be necessary at runtime. Okay, so let's get into our presentation again. If I only find it. Right. Now, if you bear with me up until this point, you might be thinking to yourself, wow, this GraalVM thing, it's actually pretty good. Like, really, really good. a bit too good to be true, in fact. And if anywhere throughout this lecture you've thought this to yourself, you find yourself having those doubts, then unfortunately you're right. So, well, if you've worked in software engineering for long enough, then you might have realized by now that we never get like really cool stuff without any trade-offs, and it's very similar in this case. So now we'll go through a couple of reasons why you might actually want to reconsider if GraalVM is actually a good solution for your next project. Right, so number one being limited reflection. I actually know a couple of people that would say that's a good thing. But however you like to look at it, if your application relies heavily on reflection, then there might be some additional configuration that's going to be needed. There might be some code workarounds needed as well. And actually, one of the popular libraries that doesn't work with GraalVM is Mockito. And it's exactly because of that reason. So if you're using Mockito tests or using Mockito in your tests, then it probably would be best to exclude those tests from your project. Some less popular libraries I could mention is like deep learning for J, for instance, for machine learning. The full registry of libraries that were successfully tested with GraalVM is available on GraalVM's website. If you'd like to use a library that's not on the list, then your experience may be pretty random. Some of the parts of the functionalities of those libraries may work, others not so much. Or it could just be working fine, just no one found time to prepare some extensive tests for it. Number two, lack of dynamic class loading. GraalVM native image compilation does not support dynamic class loading. It's actually a pretty common thing to be used in libraries and frameworks. So if you'd like to use some frameworks or some libraries that actually require dynamic class loading, then it might be possible, but also there's going to be needed some workarounds. And if you're planning your project and on the planning stage you have to plan some workarounds, that's probably not a good start. One of the libraries I can mention here is Log4j. If you dive into a rabbit hole deep enough, then you might actually get it to work. But as of today, there is no official support for native image builds. Longer build times. It's actually something I've mentioned today already, and it actually might seem to be pretty minor in comparison to the previous two. But there's been plenty of talks in Devoxx in past years already about how this can affect your day-to-day work. And especially since GraalVM build times can range from like 15 minutes up to 20 minutes, which is a significant portion of your day. Additional level of complexity. So from what you've seen today, you might be thinking to yourself that, well, working with GraalVM is just as simple as selecting a new profile, right? And if you're using like major frameworks like Spring or Quarkus or Micronaut, it can be as easy. Although if you weren't to use any of those frameworks, then that might require apologize. Then there might be much work necessary to produce a working image. There might be there might be codes that you might have to write a bit differently that you normally do. There might be some other chores that you have to do every time you start your project. So just make sure you consider all of your pros and cons, and make the decision about using GraalVM very early into the project to make sure that you won't have to overhaul your entire code base just to use GraalVM ahead of time compilation. Additionally, we could also mention here that if you have some beginners or junior developers in your team that are still learning the ropes and figuring out good practices, then you might end up having to reiterate that it's not the way you would normally do things, just so they know the typical code of conduct of writing functionality for traditional JVM. Number 5, early stage of adaptation. This may sound a bit strange, since the built-in support is Spring. It was introduced in 2022 with Spring Boot 3. And in Quarkus, it was, I think, supported from the first production release in 2019. But unfortunately, even today, your experience working with both of those frameworks can range from everything went perfectly smoothly to I googled the error and got 0 results. One of the stories from my personal experience I can tell you is when me and my team were writing what seemed to be a dream case for use of GraalVM ahead of time compilation. It was about generating documents for the user of our system. And we did it. Everything worked perfectly. We're so happy with ourselves up until a small change request came in. And what we are supposed to do is just to update one of the in-house libraries. And as it later turned out, the new version of our in-house library was using reflection. I think it was JSON for deserialization or something. I don't remember all that well. But yeah, what seemed to be a small change request turned into a real pain and a lot of work. So really make sure you consider all of the pros and cons, and so you can properly assess the risk of something like that happening within the lifetime of your application. Right, so I hope today I explained clearly and in unbiased of a manner as I possibly could the current state of the matter. So walking out of this lecture, you'll be able to make an informed decision about whether GraalVM ahead of time compilation is actually a good idea to use in your next project. Right. If any time throughout this lecture any questions popped up, or maybe you'd like to chat, you can find me for the rest of the conference on the ground floor at Dativ stand. Right. It's a very important also to answer the very question in the title of our lecture. So, is GraalVM the cure for serverless Java skills? And well, the question is as frustrating as you can imagine, and it depends. We went through some of the examples where the use of GraalVM could be groundbreaking, but do keep in mind that there are also some issues with it. There's also some drawbacks. So you might want to reconsider and make sure that GraalVM provides exactly what you need for your next project. So as I stated before, you can find me at the Dativ stand. Of course, I highly recommend you visit anyway. If you like playing around with new technologies, in Dativ we like that too. So make sure to come over, let's chat, and maybe you hear something you like. And with that, I'd like to thank you all for coming to the lecture, and I hope you have a great rest of the conference.